Starting in Chapter 2, we're just going to review some concepts from college algebra. We're going to remember how to evaluate a function, evaluate a piecewise function. We're going to look at the graph of a function and find the domain and range and answer some other questions. And then finding the domain of what was called a rational function. So let's just review of how to evaluate a given function. So here's our given function, and it's asking us to find f of -3. What does that mean to do? It means to substitute in wherever there's an x, we're going to replace that x with -3. You may notice that I use parentheses, and that helps me just keep straight the order of operations. So I know I need to square this first before I multiply by 2. Then I'm going to multiply those together. I'm going to get -18. And now I just have subtraction across, and hopefully I've done that correctly. Let's see. Nope. Let's try again. So that's -21. Yep, -26. I believe that is correct. Let's try f of 0. Now that's always easy because doing arithmetic with 0 is pretty easy. So this is going to be 0 times -2. That's 0. That's 0 minus 5 is -5. Now let me just remind you what we are doing is we're actually finding points on a given graph. So if we were to graph this, one of the points would be when x is 0, y is -5, and here x is -3, y is -26. Again, just some reviewing concepts if you haven't seen your algebra in a while. So f of 1, again putting in 1 everywhere there is an x, so that's going to be 1 times -2. So let's see, that's -1, that's -6. So f of 1 equals -6, and again that would be the point on the graph when x is 1, y is -6. Now look at these weird things. It says to plug in a letter in place of a letter. Yes, we sometimes do that in our algebra classes. So if I want to find f of a, everywhere there is an x, I'm going to replace it with a. That's pretty easy because you're just really rewriting the problem with a's instead of x's. And yes, that's your answer. But what about f of -a? Same thing, except you just have to be careful of your signs. So if I square that, that's going to be positive times that negative. So that's going to be -2a squared. That's going to be -a minus 5. So almost the same as this one, but I think we differ in that sign. Again, just evaluating a function. This function is called a piecewise function because we have two pieces. We have this piece for the domain, if you recall that, those are your x values, for the domain where x is less than 1, and then we have this piece when the domain is greater than or equal to 1. So here we asked to find g of 0. So your question is 0 less than 1 or is it greater than 1? Well, of course it's less than 1, so that means I'm going to use the top piece to evaluate that function. And again, all of that is 0 plus 3 is 3. So g of 5 is 5 less than 0? Is 5 less than 1 or greater than 1? Well, of course it's greater than 1, so I'm going to use this piece. So I'm going to put in, that's a 4, so I'm going to put in 5 plus 4, the square root of 9 is 3. So when x is 5, y is 3. Now 1, well 1 is not less than 1. 1 is greater than or equal to 1. See that little bar? That means equal to 1. So again, I'm going to use the bottom piece, and I get the square root of 5, which I cannot simplify. Don't need a calculator, just leave it as the square root of 5. And then one more example, negative 2. Again, is that less than 1 or greater than or equal to 1? It is less than 1. So I'm going to use that top piece. And again, making sure I follow my order of operations. So I need to square that. Then half of 4 is 2. Add those together and I get 5. So just looking at what is called a piecewise function. So these questions refer to this given graph. So the first one saying find f of 0. Well, we can't plug 0 into anything. It's saying when x is 0, what is your y value? That's really what that says. So look at my graph. Of course, this is my x-axis, and this is when x is 0. So when x is 0, y is 4. So f of 0 equals 4. This next question says, when x is negative 2, what is y? So again, I go out here at negative 2, and I say, there's a dot. When x is negative 2, y is positive 2. Now the next two questions really are the opposite. This says find x. So this says, when y equals to 0, what is x? Okay, so where is y equal to 0? It's right here. So, wait a minute. We've got 2 points. So this point is when x is 2, y is 0. And this point is when x is negative 3, y is 0. So x equals negative 3 and positive 2. Same thing here. It says when y equals to 2, what is x? Okay, so I'm going to say, alright, so let's see, when y is 2. So when y is 2, that's when y is 2. Do I hit the graph? Yes, I do. 2 times. So this point, x is 1, y is 2. And this point, we already have written that down. So what are our x values? X is negative 2 and positive 1. Finding the domain. Remember, the domain are your x values, and you want to go from left to right. So what is your leftmost endpoint on this graph? Well, right here. So what is your x value? 1, 2, 3, negative 4. And the furthest right it goes is 1, 2, 3, 4, 5, 6, 7, 8. So our domain is negative 4 to 8. That's called interval notation. The brackets mean that those points are included. Another way you could write this is the algebraic notation, where x is between negative 4 and 8, including those points. But I believe WebAssign and my test, they're going to ask you to write it in interval notation. Okay, what's the range? Those are my y values. And this is a little bit backwards to us because we really want to go from the bottom, because that's the lowest, to the top. So how low does this function go? How high does this function go? So here's my lowest point. Here's my highest point. So my lowest y value, 1, 2, is negative 4. And my highest y value is positive 4. So my range goes from negative 4 to positive 4. That's a little bit light. I think I'm just going to rewrite that. And again, you could write it like this, but you need to make sure that you use the letter y, because those are your y values. So far you should just be feeling rather comfortable. Review from some previous algebra classes. Now we're going to look at the domain of specifically rational functions. But before we start with rational functions, we always assume the domain to be all real numbers. And then we have some exceptions. So I want to look at this problem right here, number 4. This is what's called just a polynomial. If you were to graph that, it would be a parabola. You might remember that. And this domain is all real numbers. And we write that from negative infinity to positive infinity, always with parentheses because you can't really get there. But let's look at those exceptions. A rational function, which means a fraction, where there is a variable in the denominator. So like numbers 5 and 6 and 7. We can never divide by 0. You can pick up the fanciest calculator and try to divide by 0, and it's going to tell you error. So how do we find what values x can be in a rational function? Well, we don't want to divide by 0. So we're going to set the denominator not equal to 0. So 3x plus 6. That says, hey, I'm not dividing by 0. And I'm going to solve. So I'm going to subtract 6 and divide by 3. So my domain is all reals except negative 2. Because if I put in negative 2 for x, then I'm dividing by 0, and that's a big no-no. But any other number, I'm okay with. Okay, so we're going to set the denominator not equal to 0, because I don't want to divide by 0. And now I have to remember how to factor a trinomial with a coefficient of 1. So I know x times x. So basically you want to say what multiplies to get positive 6, but adds to get negative 7. And those two numbers would be negative 6 and negative 1. Those add to negative 7, multiply to positive 6. So then we set each factor not equal to 0 and solve for x. So that means these are all reals except 6 and 1. Number 7 is the same type of problem, but the reason why I'm putting it in the examples and on your homework is to help you review how to factor a trinomial without a coefficient of 1. There's lots of different methods, the box method, the grouping method, all kinds of. I use the trial and error method. Meaning I say what multiplies to get 6? I've got 1 and 6 or 2 and 3. What multiplies to get 5? 1 and 5. And I try some stuff. So most people are going to try 2 and 3. And you might try the 5 and the 1 there. And I think I just got lucky. Because I multiply that together, that's 15x. That's 2x. And if I make this negative and this positive, I get negative 13x in the middle. I really was trying to make it not work. I just guessed right. If that didn't work, you would just rearrange your numbers. But you need to make sure you know how to factor a trinomial for this class. So again, I'm going to say this not equal to 0. So this needs to be negative and this needs to be positive. I'm just going to write this a little bit neater. I'm going to check it one more time. If I multiply 2 times 3, I get 6. 2 times 1 is 2. I get negative 15. Add that together, I get negative 13. And my last check is negative 5 times positive 1 is negative 5. So I think I'm okay. So again, I set both of these not equal to 0 and solve. So I get x does not equal to 5/2 and x does not equal to negative 1/3. So again, that says that x can be all reals except those two values. So you just need to know how to evaluate a function by putting some numbers in, doing some calculations, how to evaluate a piecewise function, as in which piece do you use. Looking at a graph, can you find the domain and range and find some values? And then that last thing we just covered, was how to find the domain of what's called a rational function, one with a fraction.